So where we are here. Okay. So what is the array list are non-synchronized means? What is mean by non-synchronized? Suppose if you have one source, okay, and if you have a two threads, okay, suppose if you have two threads and the one resource, so what it will do, this both the threads will execute this resource at the same time. Okay, both the threads will be execute the resource at the same time. That is called as the non-synchronized. Okay, and if you are using the synchronization means, bus this thread will be go, this thread will be acquire the lock. After that it will be execute what are the things which are present inside the synchronized area. Okay, after that after this completion of this thread, this another thread will be go, and this thread will be means execute whatever the things present inside the synchronized area. But our array list are the non-synchronized means all the thread will be execute that resource at the same time. Okay, all the threads will be execute that resource at the same time. That is meant by the non-synchronized. So these are the some properties which are present inside the array list. If anybody will ask you what is meant by array list, what are the properties of array list, so you have to tell this thing. Like array list is our index based data structure. Array list can store the different data types. Okay, array list can store the duplicate values. We can able to add multiple null values inside the array list. It will follow the insertion order, but it will not follow the sorting order, that is in ascending or descending order. Array list are the non-synchronized means multiple threads are execute the same resource at the same time. Okay, after that if you notice here the another thing, suppose the linked list. Okay, here inside the list we have array list, linked list, vector and the stack. Okay, inside the array list it is a index based, then it is allow the heterogeneous type of data. It will allow the duplicate values. It will store the null value, many number of null values. Then insertion order also it is following. After that sorting order also, and non-synchronized. If you notice here inside the linked list properties also, so these are the linked list properties. So linked list also index based data structure. It will also add the heterogeneous type of value. After that it here also it is it is allowed to store the duplicate values. After that here inside the linked list also we can add the multiple values. Insertion order it will be maintained, sorting order it will not maintain, and it will not follow it is not a non-synchronized. Okay, means whatever property the list interface have, okay, whatever properties list interface have, same properties will apply for the array list or the linked list and the stack and the vector. But stack and the vector are the legacy classes. Okay, here if you notice that stack and the vector, this both are the legacy classes, and one property difference is there only, that is the these are the synchronized. Okay, vector and the stack are the synchronized. This is the only one difference between the vector, stack and the linked list and the array list. Okay, here see if you see the stack vector also, so array vector is a array list index based data structure. After that vector can store the heterogeneous type of data. It will store duplicate values, multiple null values it will be allowed. Insertion order, sorting order it will not allow. After that synchronization. Okay, vector are synchronized collection means it will allow one thread to execute the resource at this one time. Okay, at each time. So this is the difference between the legacy classes and the array list and the linked list. We will see one by one, but I told you the difference means if you know this difference, so you will be easily understand. Array list, linked list, vector and stack all have the same properties, but vector and stack are the legacy classes. Because of that, these both are the synchronized. Okay, and array list are and linked list are the non-synchronized. Only one difference is there. Okay, now we will see some methods of the collection interface. So these are all the methods which are present inside the collection interface. So first method we saw, that is the add. Now we will try to see the add all method. What is the use of this add all method? Suppose if we have a this AL. Okay, inside the AL we have a multiple values like a 10, then 1, 99, 50, 63. Okay, now suppose I have made the another collection object. So I will make that array list, new array list. Suppose I am giving this name as a AL2. Okay, this is the AL and this is the AL2. Now if I print it here, system.out and AL2 I will print. So what will be the value we will get it here? What will be the values we are getting here? We have we have not added any values here. Here inside the AL we have added multiple values. Inside the AL2 we have not added any values. So what will be the output? We will get it here. Error or empty. Empty. Okay, Shiva is saying empty. Any person have any other answer? Anyone have any other answer? Like in error it will be give like that. Anyone have any other answer? What will be the output we will get it here? See, here we have added multiple values like al dot add nothing. Okay, here we have added multiple things, but here we have not added anything. So what it will be print? Simply see, if I run this one, so it is printing the empty box. Okay, it is printing the empty, means we have not added anything here, no. So that's why we are getting the empty now. So what is the use of add all method? Suppose inside the al, see, inside the al we have this much thing like 10, then 1, 99, 50 and 63, and inside the al2 we don't have anything, like because we don't added anything. Now suppose sometimes what we want, whatever elements we have inside the al1, now I want to add the same element into the al2. So we can add like that also, like al2 dot add. First I will add 10, then 1, then 99, then 50, like that we can add, like we can add. But what is the use of add all method is, if we add the same element, if we want to add the same element of al into the al2, so that for that we are using the add all method. Okay, for that we are simply using the add all methods. How we will use that? So al2, then we have to use add all method. Okay, inside that we have to use the another collection, like this is the collection object. Okay, inside that we have this much element, this, so all the elements I want to add into the al2. How we will add that? Simply we have to use al here. Okay, so what I wrote here is al2, then add all, and then simply I wrote here al. Now see what will be the values we are getting into the al2. Here we are printing al, and here we are printing the al2. Before that it is empty. Now see, same element we have added here also, that is 10, 1, 99, 50 and 63. Okay, if you want to add the same element of this collection into the another collection, then we will use the add all method. Okay, then simply we will use the add all method. Now we have remove method also, remove all method also. Okay, so we will try to use the remove method. So I will comment this thing. Suppose I want to remove anything, so how will use that? Simply we have to use al dot remove, and here we have to write the index also, or you can use the element also. So suppose I want to remove the 99, so on which index it have? So 0, 1, 2, so I will use here 2 index. Okay, now simply after removing I will print that, so system dot out, and I will print that. Okay, so this is before print. After that I will remove the second index, which is the second index, 0, 1, 2, then 99 it have to remove, and after that it will print 10, 1 only, 50, 63. So you will see that. So see, it is printing only the 10, 1, 50 and the 63. Okay, so if you want to use the remove method, so you can remove the method like that. Okay, but see, suppose we have here Java. Okay, now I have to remove it with the help of elements. How we will remove that? So we can remove with the help of index also, or we can directly use the object also. Sometimes if you write the integer here, no, so it will consider as an index only. But if I consider right here the Java, now I want to remove the Java from here, and if I write here, if I run this one, see, first we have added the Java, now it have removed the Java. Okay, so this is the use of our remove method. Now what is the use of the remove all method? So what we will do, simply same element will try to edit here. Okay, but simply we have to write here al2. Okay, and if I save this one, and if I run this one, the same element we have added into the al2 also. So why I have added that thing, so I tell you. Okay, now inside this one we have this much element like 10, 1, Java, 50 and 63. Now I will use here the method like al2 dot remove all method, and I have added here al. Okay, now if I use here system dot out, and if I print here al2 now again, so see what will be the output we will get. See, it is empty now, that is the al2 is empty. But if I add here the another thing, that is the al2 dot add, and here I have added the Java. Now if I added here Java, see Java will be removed or not? Java will be removed because Java it has special purpose. If I use here C++, okay. So C++ it is not removing, means whatever similar element the AL1 AL have, so that all the elements will be removed from the AL2. See C++ is not here inside the AL, so it will not remove the C++. Okay. Now suppose inside the this one also, inside the AL also, if I write here the C++, see C++, if I add it here, so this time it will remove the C++ also. Wait a minute here. Okay. See, if we have added here C++, so it will remove the C++ also. So same like that, we have another method also, that is the retain all method. Okay, so here we are not using the retain. See, means inside the removal, what it will do? What are the same elements which are present inside the AL, that will be removed from the AL2 also. So suppose 10, it have 10, so 10, 1, 1, Java, Java, 50, 50, 63, 63, C++, C++. So it will remove all the elements. Suppose here we have a, suppose C, this time in this one we don't have any C++, but it have the C++, so it will not remove the C++. The same like that we have a retain all method also. See, now I will use here retain all method. So what retain all method is do? See, if I run this one, see, so it is means it is keeping the similar elements, but it is removing the unsimilar elements. See, first we have 10, 10, 1, 1, Java, Java, then 50, 50, 63. C++ we don't have. So what it will be do? If you use the retain all method, so it will remove the C++, but similar elements it will be keep. Okay, similar elements it will be keep, but the unsimilar element it will be removed. Okay, similar unsimilar element it will be removed. So that is the use of the retain all method. After that we have a clear method also, is empty method also, iterator also. So I will show you. So what is meant by clear method? So what is meant by clear method? Why we are using the clear? Suppose if we have a multiple elements in the list, okay, inside, if you have multiple elements inside our collection object, so this is the collection object. Inside the collection object we have multiple elements type 10, 1, Java, 50, 63. Now I want to remove all the elements. So for that simply we will use the clear method here. Okay, clear method will remove all the elements from our collection object. EL I am using here. If I run this one, so see, it have removed all the elements from this AL1, from the AL. Okay, it have removed all the elements from the AL. So why we are using clear? If you want to remove all the elements from our collection object, so for that simply we are using the clear method. Okay, simply we are using the clear method. After that, is empty method. So why we are using the is empty method? If our collection object is empty, that time it will return true. If our collection object is not empty, that time it will remove false. Okay, so that is the is empty method. Same. After that, iterator. So what is the use of iterator? So simple iterator means what? So inside the collection we have one iterator that will iterate the value one by one. Okay, that will iterate the value one by one. So how? The symbol, I will remove this thing from here. Okay, I will remove this thing from here, and here what we will do, AL1, AL, sorry, AL is our collection object. Inside the collection AL, so we have a one method that is the iterator that will return one iterator object. So now we got a iterator here. Okay, now we got a iterator here. So with the help of that iterator, we can iterate the value one by one. So how we'll get that? So simply while we will use it here, and with the help of that itr dot next. So this iterator have three main method. That is the next method, has next method, and the another method we have, that is the remove method. Okay, that is the remove method we have, that is the remove, has next, and the next method we have inside the iterator. So simply we have to use here has next. I will tell you why we are using here the has next and all. Okay, itr dot next. Okay, so if I run this one here, so see what it will be print. It is printing one by one, like 10, then 1, Java, 50, and 63. So how it is printing like that? So simply we'll copy this thing from here, and simply we'll come here into the page. Okay, so this is the page. Okay, so now we have created the object here first, that is the earliest object. Inside the earliest object, what we have is 10, 1, Java, 50, and 63. So what it will do, simply it will create an object. Inside the object, we have added the multiple things. So which are that things? First, we have added a 10 here. So 10. After that, we have added 1. Then we have added Java here. After that, we have added here 50, and after that, we have added here 63. And what is the name of this object? That is the AL. Okay, so this is the AL. When we will create a iterator, it will create an object and it will point out this cursor. Iterator means cursor. So what it will do? It will create a cursor like that. Suppose this is a cursor. So it will create a cursor like that, iterator. Okay, so what it will do, first this cursor will point out to the empty position. So whatever empty position it have, so it will point out to this position. After that what will happen? Suppose if we have here, okay, suppose if you are using the iterator dot has next method. Okay, if you have this method iterator dot has next method, so what it will do, it will return true or the false. The has next method will return the boolean value, that is the true and false. If we have any element, okay, if you are using the has next element, what it will do, this cursor will point out to the another thing. Okay, this pointer will jump from the empty space to the element, and it will return that. This method will ask now, it have any element or not. So this have the element now, right? This have the element. So what is the element? That is it 10. So it will return true. And if while return true, so it is come into the while block, right? If this condition will be true, so it will come into the while block. And what we have wrote here inside the while block, that is itr dot next. And what is the use of next method is, this method will return the element. Okay, this method will return the element. So what will it return first? That is the element. So which is the element here? 10. Okay, so it is the 10 it will return. So 10 will be print on the console. See, 10 is printing on the console here. After that, that cursor will be point out to the space. Okay, that point out will be that cursor will be point out the space. Then again we are using the has next method, that we are using the again we are using the has next. This cursor will shift into the another element. Then it will be asked, it have any element or not. So it have the element, so it will return true. It will come into the while block, right? And itr dot next, it will return the element. So which element we have? That is the 1. This cursor will shift to the another piece. Okay, when then another thing we are using, that is the has next method. This cursor will shift to the another element again, that is the Java. So it will ask any element it have. So yes, we have any element, that is Java. So it will return true, it will come inside and it will return the element. So which element we have now? That is the Java. Again this cursor will shift to the space. Then we are using has next method again, right? This cursor will shift again to the this point, that is the element. It will return true again, because we have here the element. So it will return true, so it will come here and it will return the element, that is the 50. After that, same like that, it will happen like that. After that, it will come in last. After 63, it will come into the last. And again, if we are executing this method, that is the has next method, so this cursor will point out to the another things, and here is the space only, we don't have any element. So what it will be returned this time? That is the false. And this loop will be stop it here. And what will be the value it will print? This is the 10, 1, Java, 50, and the 63 here. See, 10, 1, Java, 50, and the 63 here. So that is the use of our iterator. How our iterator will work? Like a cursor. Iterator is depend on the cursor only. This cursor will be shipped from this to this, like that it will be shipped. Okay, that is the use of our iterator. If you want to iterate the values one by one, for that we are using the iterator only. Okay, for that simply we are using the iterator. Okay, now what is the use of this method? That is the boolean value. It will return true or false. If we have elements, then it will return true. If we don't have any elements, it will return false. And what this method will be do? This method will be return the element. Okay, now inside the iterator we have another iterator also. Inside the list interface we have another interface also, that is the list iterator. Okay, we can iterate the list element by iterator and the list iterator. So what is the use of list iterator? Suppose I told you, like, inside the iterator we have a three method. There is the has next method, and another method we have, that is the remove method. But if we use the list iterator, so suppose I'm writing here list iterator, it will also return one iterator. Okay, it will also return one iterator, that is the list iterator, return one iterator, that is the list iterator only, list iterator. Okay, it will also remove return one iterator, that is list iterator. Okay, and with the help of this list iterator, we can iterate the values in the previous manner also, means inside the backward direction also, and inside the forward direction also we can iterate the values. See, if I told you the method, like it have the has next method, has previous method. Has previous method means what it will do, it will iterate the values into the backward direction also, inside the forward direction, as well as into the backward direction also. So that is the use of our list iterator and the iterator. Iterator iterate the values into the forward direction only, but list iterator can iterate the values into the backward direction also, backward as well as the forward direction also. So inside the list only we can iterate the values inside the forward and the backward direction with the help of list iterator. But say don't have any list iterator, so what it will do, it will iterate the values into only in the forward direction, not into the backward direction. Okay, so that is the use of our iterator and the list iterator. Okay, so anyone have any doubt till here? Anyone have any doubt? Anyone have any doubt till here? Okay, okay. No, okay. So now we will see the another thing, that is the array list. Array list we saw. Now we will see the linked list. Okay, so array list is based on the concept of growable or the resizable array, but linked list is based on the doubly linked list or the circular linked list. So what is it means? So it will store the values on the basis of doubly linked list or the circular linked list, but array list can store the values on the basis of growable or the resizable array. All the properties which we have inside the array list, same property which we have inside the linked list also. Okay, all the properties we have inside the array list, that will be present inside the linked list also, because both the classes are inheriting the same interface, that is the list interface. Means whatever properties the list interface have, that will come for the all the classes which are implementing the list interface, right? So now we will come into the linked list. So how it will store the values, as you knows that, so array list can store the values onto the growable or resizable. First value it will store here, second value here, third value here, fourth value, sixth value, sorry, sixth value, till sixth value it will be stored here, right? But how it will be store the value, that is the linked list, how it will be store the value. So it is using the double linked list. So what is mean by double linked list, how it will be follows that. So simply I told you, means, so how double linked list will look like. So it is like a node. So this is the node. Inside the node, what it have the three compartment into the node. This is the data structure part. Okay, so inside the node we have three compartment. Inside the middle compartment it will be add element. Okay, inside the middle one it will add element. After inside the previous one, what it will add, it will be add previous. It is easy only, it will add previous node address. Okay, it is adding the previous node address. After that, inside the another node, what it will be do, next node address. Okay, so inside the first box it will, what it will do, inside the first box what it will do, it will add the previous node address. Then inside the middle box it will be add the element, and it will into the another box it will be add the next node address. So how it will be work? So simply we will try to create one program, we will try to create one program here. So simply what we will do, we will create a linked list first. Okay, we will create a linked list first. So new link list. Okay, so simply I am creating a linked list, and inside that what we will do, simply we will try to add the element. Okay, so linked list we have created, sorry, linked list. Okay, inside the linked list we will try to add the values ll dot add, not add all, add only, and here we will add a element. So first I have added 10 here. After that ll dot add, I am adding another element, that is the 45, or we will add some string values here. we'll see it will able to can be able to add the heterogeneous type of values into the linked list or not. Okay, inside the this one we will try to add some character value, and at last we'll try to add the float values also. Okay, we will try to print it simply system.out, and LL will print. If I printed this one, so 10 Java C and 1.2 will be print. Okay, so see 10 Java C and 1.2 it is printing on the console. Okay, so it is following the insertion order also. If you notice here, see inside the linked list are the index based data structure. Linked list can store the different types of data. There is the heterogeneous type of heterogeneous type of data. It is stored here inside the uh, inside the linked list. It is storing the heterogeneous type of data also. After that, linked list can store the duplicate values also. If we add same value multiple times, so it will be allow that also. After that, multiple number of null values also we can add. Insertion order it will follow. Sorting order it will not maintain. And after that, linked lists are also non-synchronized. Means all the threads will be execute the same resource at the same time. Okay. Now another thing is that see we have added here 10 Java C 1.2. So how it will be add the values? So on the basis of linked list, in the linked list it will add the values on the base of w linked list. So how it will be add? So simply it will create a node like that. Okay, it will create a node like that. Okay, so it will create a node like that. Suppose what how much elements we have. Okay, how much elements we have inside this one, that is the 4 elements. So it will create a 4 nodes here. So I will create this 4 node here, second, then I will create a third node here. Okay, then I will create a 4 node also. So it will create a 4 node like that. Okay, and every node have the different node address. So suppose it have the 1001. Okay, suppose this have the one this node address having the 1002, then this node address is another thing, there is a 1003, sorry 3, and this node having the another node address, there is the 1004. So how it will be add the values inside the middle compartment? What it will be the properties of both linked list and array list is same. Yes, properties are same, but it will add data structure very different. It is following the double linked list, and array list follow the growable or the resizable array. Okay, so here inside the middle part, what will be add? That is the elements. So which is the element we have added first? That is 10. So it will be add 10 first here. Okay, so it will be add 10 here. Then what we have added here? Suppose Java CN 1.2. So it will add here Java. Then here we have added C, and it have added the another thing, that is the 1.2. Okay, now it have added the element. We added the element successfully here. What it will be do now? See inside this compartment it will add previous node address. Inside this compartment it will add the next node address. So before that any node is there, so no. So what it will be add here? That is the null value. Okay, if no node address is there, so what will be add there? That is the null value. Now inside this compartment, what it will be add? That is the next node address. Which is next node? This one. And what is the node address of that? That is the 1002. So it will be add 1002 here. After that here, if you talk about the another node, here it will be at previous node address. So what is the previous node? This is the previous node. So 1001 it will be added here. And what is the next node here? That is the 1003. So 10003 it will be added here. Same like that, if we talk about the third node, so this is the 1002. And what is the next node for this one? There is the 1004. So it will be at 1004. These are the node addresses: 1003, 1002, 1004. Okay, after that here 1003, and suppose after that we don't have any node address, we don't have any node after that, so it will be add null here. Okay, so this like linked list will add the values. Okay, and there will be one cursor that will point out to both the part. Okay, like this one, and inside this one, in the both direction it will be 0.2. Okay, for all one it is same, for all the thing it will be same. Oh, sorry. Okay, it will be, there will be cursor that will point out to both the thing. Okay, so here linked list is looking like that. First we have a node, inside the node first compartment will be point out to the previous node address, and another compartment will be point out to the next node address, and inside the middle we have a element like that. It will be point out to like that. So it will be means that is the linked list can store the values on the basis of doubly linked list. Okay, on the basis of doubly linked list it will be add the values. And how doubly linked list will look like? So this, like, it will create a node. Inside the first compartment it will add the previous node address, middle compartment it will add the element, and inside the last compartment it will add the next node address. And there will be the arrow that will point out on the both the direction. And same properties we have inside the linked list also. It is an index based, then it will store the heterogeneous type of data, duplicate values, then multiple null values, insertion order also it will maintain. Inside a linked list it will not follow the sorting order, and it is not a non-synchronized. Okay, it is non-synchronized data structure. Okay, so these are the linked list and the array list. So anyone have any doubt till here? Anyone have any doubt till here, guys? Anyone have any doubt? Properties are same. All the means what are the methods which are present inside the collection, that all will be present inside the array list, linked list, vector and stack also. All the property, all the classes, hash set, linked, hash set, reset, what are the methods present inside the collection, that all will be present inside the all the classes. Okay, all methods are the same, just only the small properties are there. Both the array list and linked list have the non-synchronous only. Yes, both are the non-synchronous only. What are the properties I have wrote here? Same properties, their list and the linked list also it have. Right, but we will see tomorrow, that is the vector and stack. Vector and stack are the synchronized. How, that we will see tomorrow. Okay, so anyone have any doubt till here? Anyone have any doubt? Linked list take more time to execute than array list, means it is time complexity. Yes, yes, I showed you like that. See, what is the advantage of the linked list? Insertion and deletion operation are efficient and fast inside the linked list. Why? Why means, see, suppose if we have a array, suppose this one is our array. So inside the array, suppose we have a multiple block. Okay, suppose if we have a array like that. Okay, and suppose if you have a element here, inside the, here we have 10. Okay, here we have 20, we have a 30, here we have a 40, and here we have a 50. Okay, like that we have a multiple elements inside our array. So 60, and here we have a 70. Inside the array we have a multiple elements like 10, 20, 30, 40, 50, and 60, 70. So now I want to delete this 30. I want to delete this 30 from here. I want to delete this 30 from here. So how we will delete? How it will be deleted? So it will be traverse this all the elements, like 40 will be traverse from here to here. 50 will traverse from here to here. 60 will traverse from here to here. Means if we have a, now we, if you have a 7 elements, so it will be easy. It will take it will not take that much time. Suppose if you have multiple times 10,000 elements or 1 lakh element, that time it will be take lots of time, because it will be traverse 1 lakh elements, 10 lakhs elements. So it will be take more time, right? So it will be quite miss that is the linked list is quite fast. How? So suppose, see, this is our linked list. Inside the linked list, suppose I want to delete this element. So suppose I want to delete this element. So how it will be delete this element? This, only this cursor, it will be point out to the this cursor like that. It will point out to this cursor, and we don't it only have to maintain the, that is the node address. So what is the node address now? It is not a 1002 now. It will be 1003 here. Okay, 1003 here. And what is the previous node will be here? 1002 we have deleted. So only it have the 1001 here. Okay, now if you do like that here, so it will be added the values. It will not traverse any value. It will not do anything. So only have to manage the node address, and the this is the cursor. Only cursor we have to manage, and only we have to manage the node address. It will be add the values fast than the array list traverse all the elements, but if you have to add or delete the elements from the linked list, so we don't have to add traverse or anything, but just only we have to maintain the previous node address and the next node address. That's it, and we can add and delete the values. We can traverse the list in forward and back direction because we have the list iterator. And what is the disadvantage? That is the uh, it occupy the extra space for the previous node address if we don't have any element here. So till that also, okay, so till that, if we don't have any element also here, so what will be stored here? That is the null value. After that also, if we don't have any elements, so it will be stored the null value. So that is the disadvantage of our linked list. After that, insertion and deletion elements is fast. In between, if we have to manage only the previous node address and next node address, suppose if you have to delete this element, simply we have to manage the node address like that, next node address we have to manage like that, and previous node address is managed like that, and it will be add or it will be delete. So that is the linked list, which is faster than our array list. Okay. Okay. Hello. Okay. Anyone have any another doubt? Anyone have any another doubt? Yes, yes. See, array list have another uses and the linked list also have another uses. Array list are worst for the insertion or deletion. Linked list are the worst for the retrieval operation. Okay, if you want to retrieve any elements, so linked list we will not use. But array list are for use good for the retrieval. If you want to retrieve any elements, so the array list we can use. If you want to insert or delete, if you want to perform the insertion order or deletion operation, so that time linked list is best. Array list you will not base because array list traverse the element. Okay. Okay. Hello. Okay. Okay, anyone have any another doubts? Anyone have any another doubt? Okay. Okay, so today we saw what is meant by array list and what is meant by linked list. So today's assignment is that you have to create a program on the array list and linked list, and whatever the methods we have inside the collection, you have to try that and you have to submit on the group. Okay, if you are not getting any methods and all, so you can ping me or you can ping it in the group. We will definitely help you. Okay, so that's it for today, guys. Thank you for your time. I will meet